Hi everyone, this is the C# Tricks channel. Having consulted with my friends, I've decided to delve into an intriguing topic in a separate episode: binding. Get ready because it's about to get interesting. Binding refers to the process of connecting data between a source and a consumer. In this context, the source is where the data is stored, and the consumer is a visual component of the application responsible for displaying this data. In terms of MVVM, the data source is the view model, and the consumer is the view. Understanding this division of responsibility is extremely important. Data storage exists independently of the consumer. They can both exist without each other, and it's only through binding that the connection and data transfer between them are organized. A tangible example to consider is a radio station and a radio receiver. Both devices can fully function and operate independently of each other. The radio station can broadcast a signal without any consumers receiving it, and the radio receiver can produce noise even without receiving a signal from the radio station. In WPF, binding is often defined in XML markup. Let's consider an example of creating a binding. On the screen, you see an application that includes a view model called ServerTimeViewModel with a public property UTC value, and the main window markup containing a text block control for displaying the current time. Our task is to describe the binding that connects the UTC value property of the view model with the text property of the text block control. Since I explicitly specified that the Windows view uses an object of type ServerTimeViewModel as its data context, all public properties of this view model will be accessible and visible to the view. To create the binding, we'll set the text property of the control using the following format. Within curly braces, we'll specify the keyword binding, followed by the name of the property from the view model, which is UTC value. For WPF, this would be in order to create a data binding at the time of the view's creation. We'll launch the application and observe that the value appears on the view as expected. The binding is working as anticipated. Here we encounter the fact that time doesn't stand still and is constantly changing. Let's enhance the view model so that the value of the UTC value property changes every second via a timer. Let's restart the application once again. As you can see, the view displays the value from the view model at the moment of the view's creation, but doesn't update it. The main issue here is that the view doesn't know that the value in the view model has changed, and the view model doesn't know about the existence of the view and cannot notify it of the change. This problem can be solved in two ways. The first approach is to make the view continually poll the view model for changes. However, it's easy to see that with a large number of views and view models, this approach would be overly resource-intensive. The second approach is to provide the view model with a mechanism to notify others of changes without knowing about the existence of those consumers. This mechanism is typically implemented using events. An event is essentially syntactic sugar over a regular delegate list. From the outside, a consumer of the event can subscribe to or unsubscribe from it. Subscribing means adding a method that matches the signature to this delegate list. Unsubscribing means removing the method from the delegate list. Importantly, from the outside, it's impossible to directly access this delegate list. Only the owner of the event can iterate through this list and invoke each method. This process is called invocation, and the delegate list is referred to as the invocation list. If you follow this approach, you can create an event in the view model with a delegate signature that allows passing the name of the property in the view model that has changed. Since the view knows about the view model, it can subscribe to this event by putting its method there, which the view model will call when necessary. At the same time, the view model will continue to know nothing about the view, as this method is anonymous to it and contains no data about the owner of the method. At the moment of invoking this method, the view will reread the data of the specified property and re-render it. Someone might wonder, how does this relate to binding? You've probably heard of the interface called iNotifyPropertyChanged. It includes a single member, the PropertyChanged event. This interface is used by the WPF infrastructure to create binding. When a binding is created, WPF checks whether the data context object implements this interface. If it does, WPF automatically subscribes to the PropertyChanged event, and when the view is released, it automatically unsubscribes. By implementing the iNotifyPropertyChanged interface in the view model, you enable the ability to notify the view of changes in the view model. This allows for seamless communication between the two components, ensuring that any changes in the data are reflected in the UI without the need for manual intervention. Let's implement the iNotifyPropertyChanged interface in the view model. Now, in the timer handler, let's invoke the event's invoke method. Note the warning. If the event has no subscribers, it will be null. Therefore, we need to check for null before accessing the event. Let's use the Elvis operator. As the sender, we'll pass ourselves, the view model, and as the second parameter, we'll pass the event argument, putting the name of the updated property in its constructor. I strongly advise against specifying the property name as a string constant. The reason is that if you ever want to change the property name, you'll have to remember to also change the string constant with that name. Instead, it's better to use the name of expression, which has been available since C#6. Name of converts the passed argument to a string. Now let's run the application again. Now the time updates every second and the binding works. Excellent. The purpose of this video was to explain how data binding works so that it's not a black box for you in future episodes. I will delve into more detail about data binding in the next episodes. That's all for today. Enjoy developing.